Okay, we are going to talk about one of the problems in our book, chapter 6, question number 12. We first open up the file, Excel files that the data belongs to. We are going to open it up. Okay, chapter 6, dataset is opening. Okay, we are going to just say okay to it. We say okay. Okay, so we have the list of dataset for each question in chapter 6. Now I'm gonna open up the problem as well. I'm trying to have a room here for both the question and also the Minitab screen. What we could do is we can make it a little bit larger. Okay, so I'm gonna first read the question to you. Let's see what this. Okay, this is a question. Chapter 6, question 12. The net weight in ounces of a dry bleach product is to be monitored by X bar and R control charts using a sample size of n is equal to 5. Data for 20 preliminary samples are shown in the table 6E7. I'm going to show you the table too. A. Set up X bar and R control charts using these data. Does the process exhibit statistical control? B. Estimate the process mean and standard deviation. C. Does fill weight seem to follow a normal distribution? D. If the specifications are at 16.2 plus minus 0.5, upper specification limit and lower specification limit, we mean by this. What conclusions would you draw about process capability? E. What fraction of containers produced by this process is likely to be below the lower specification limit of 15.7 ounces? Yeah. Okay, that's the question. Okay, we are gonna start solving this problem. The first part was about setting up X bar R control charts. So we go to stats, we go to control charts, we go to variable charts for subgroups, X bar R chart. Our data set is all observations for a chart are in one column. So that's really true. Okay, it is right here. 12 is here. As you look at here, C25 and C26. The sample 1 and this weight 1. Sample 1 is just numbers, for example, subgroup 1, subgroup 2, subgroup 3, etc. These are the real data set. Okay, so I'm going to click on that. Subgroup size is 5. So I'm going to write 5 in here. I'm going to click OK. Okay, this is our X bar R chart. Let's look at the R chart first, which is in here. Always look at the R chart first, sample range. And it shows that no points are out of control limits. So we are fine. Also the X bar chart, which is this, everything is fine. So we have one answer to part A. So nothing is out of control. Okay, let's go to, let's see. Okay, so this is the actual data set we are using. There are 5 subgroups here, and the sample number is 20 here. There are 20 samples, and each we got this 5 observations from each, which we call subgroup size. Okay, this is a subgroup, this is a subgroup, this is a subgroup, but the observations in the subgroup is 5. Okay, so it's the same chart we get in the question. Okay. Okay, so the second question is estimate the process mean and standard deviation. So our subgroup size is 5. X bar bar, you can find it from this graph as well. Look, so this is X bar chart, right? The first one is X bar chart, and the X bar bar is in here, 16.264. So we can copy this here to here. If I can make it a little bit bigger for you. Okay, yeah, so this is X bar bar here, and then we have the R bar here. This is the mean of the R chart. Okay, and then sigma head X is gonna be this R bar over D2. D2 you can find it at the end of the book. This belongs to the chart which is we call it factors for constructing variables control charts. This is appendix 6. Appendix 6. If you look at the appendix 6, you will find this D2 value. But be careful when you are searching for D2 value. You should look for the n is equal to 5 row. Okay, because our subgroup size is 5. So this D2 depends on the subgroup size. And you can find it as 2.326. Take the ratio, and that's gonna be it. So here there's a typo though. Okay, this R bar should be 0.505. So there's a typo here, please ignore. If you look at the graph, so you're gonna see R bar is equal to 0.505. So there's only one typo here. Okay, next we wanna, okay, does the fill weight seem to follow a normal distribution? So I'm gonna close this. Okay, cancel first. So what you could do is for the exam, what you could do is you can say either copy this graph or send graph to Microsoft Word. Okay, if you send it to the Microsoft Word, okay, let's see what happens. It's gonna open up in Microsoft Word. Let's see. Okay, retry. Let's see. It should open up. It's opening it up. Okay. Okay. So here's the Word file. So in the final, what you're gonna do, you're gonna say save as, and you're gonna browse. Let's say desktop. Let's keep it in desktop. Final exam and your name. You're gonna type it in. Final, your name, last name, and then you're gonna just save it to the desktop in the final. Okay, and you're gonna write your name here too. Okay, and then your if you want, you can write the student ID too, ID, because I'm gonna collect these. And then you should also write the question number. Let's say this is question 12. Okay, question 12 in the final. Okay, then you're gonna write it like that. Okay, so it's okay. I can close it now. No, I said I don't want to save it because I already transferred it to my Word file. And next, it says, does the fill weight seem to follow a normal distribution? We have to build the histogram of that. So we go to graph, we go to histogram. Okay, and we want the simple one. Okay, simple one, we choose our data set, which is this. I just click OK. Okay, we got the histogram as well. These are the frequency level here. Okay. and then I'm gonna again send it to the Microsoft Word. Let's see whether it sent it to there. Okay, it sent it to there. So this is part B, if you like. Okay, this is part B in question 12, and this is part A, answer to part A. Okay. Okay. Maybe I should write it somewhere here. Okay, it's part A. Okay, and save it. Always save it. Don't forget to save it, because sometimes you may have some problems. So I'm gonna okay, before I close, if you look at this, this is like a bell-shaped curve. Okay, so I'm gonna say that it is really true. I can also do one more thing actually. This shows the bell-shaped curve. I'm gonna close this. Yes. Oh, no, I say no, so cancel that. I don't want to save it, so I'm going to close it. And next, what I want to do is I want to do the normality test, probability plot. Okay. So I'm going to go to graph again, probability plot. Okay. And I'm going to choose the single one again. And choose my data. Select, I click OK. As you see, we get the same picture as in here, same graph, and these values are also the same. Okay. Since our data falls in between these two curves, and it is almost this linear line, so it lies around this linear line, this line in this band. So we are going to say it's normally distributed. We can also transfer this, send this to Microsoft Word. Probably it already did. Okay, it already did. So this is the yeah, ABC. So you understand. So it's, yeah, it just sends it where the cursor is, so you can arrange them in order later on if you like. So maybe you can move it up, high up here, yeah, and maybe more than that. Okay, you may want to put it up here in the front. Okay, you can organize that afterwards. So you can just say A here, and then B is the next one, and then this is C, and correct it to C. Okay, save. Okay, where's our cursor? I'm gonna erase that. And let's see the cursor here, and there's this part D. Okay, in part D, what is asked? So let's save it, always save it. Okay, where is it? Okay, we did this. And where's our Minitab? Okay, that's it. So I don't want to save this anymore. I'm going to close it and say no to it. Okay, good. So if I come back to this, yeah, the part D, it says if the specifications are at 16.2 plus minus 0.5, what conclusions would you draw about the process capability? For process capability, we calculate CP hat, okay, the approximate value. And the formula is as goes follows: upper specification limit minus lower specification limit divided by 6 times sigma variation is that. So upper specification limit is actually 16.2 plus 0.5, which is 16.7. So in here actually it is 16.7 minus 16.7 minus 0.5, which is 15.7, minus that then you're gonna get equal to this actually, okay, because we have the 16.2 is the same for both. So instead we just write these plus and minus parts, take the difference between these two and divide by 6 times the sigma. And this is 0.77. 0.77 is less than 1, so we are going to say the process is not capable of meeting the specifications. We can also see this on the Minitab. Okay, we can get that on Minitab as follows. So we are going to do it as follows. Okay, so we are going to go to stat again, quality tools this time, and we are going to go to capability analysis, and from here we are going to choose the normal. Okay, so this determines how well is your process. Output means customer requirements when your data are reasonably normal. In our case, our data is normal. Okay, so we are going to, so it's a single column, data is arranged in a single column, so we are going to choose get our data from here and click on that, and here subgroup size was 5. Okay, lower specification limit was 16.7, oh pardon, 15.7, sorry. Upper specification limit is 16.2. Okay, click OK. We should get the same graph. So I want to transfer it to my Microsoft Word. It should be already there. It's right here. This is the question D. Okay. Part D. And we can say that in this table, in this graph, we can get all these information. See lower specification limit, which is 15.7. Upper specification limit is 16.2 here. Other information is in here. And we have lower specification limit, upper specification limit. Look at that, right? Because since CP is less than 1, there are a lot of non-conformities. So we have CP 0.37 here computed, and it's less than 1. This result is going to be just a little bit different than what we find. It's normal, it's okay. And then, yeah, let's keep it in here. Let's save it, always save. Okay. And I'm gonna just remove it. Close it, sorry, close that, don't keep it. Okay, and next question is, what's the next question about? This is about the fraction conformities, non-conformities, right? So what's the question says? What fraction of containers produced by this process is likely to be below the lower specification limit of 15.7 ounces? So we have this, so specification limit, probability of the specification limit for the lower one, it's the probability that X is going to be less than lower specification limit, which is 15.7. So this is normal distribution in here. We have to convert it to standard normal. So 15.7 minus the mean over sigma. Yeah. And we get those information from our table up here. Where's our table? It should be here. Leave it. Put it in here. Oh no. Save it here. Okay. So we have this standard deviation. Okay. And then okay, and then the sample mean is 16.264, and then we look at the phi value of that. This is approximately this much. Okay, the Minitab process output is going to give it as ppm less than or equal to LSL, which is this. expected overall, expected within. Okay. This value is in here. Okay. So we'll get that. This is going to be it because our CP value is different here, right? Just a little bit different, but still the result is going to give us what we want. Okay, that's the end of the question. See you in the next problem.